आपका पहला सुपर टीचर कौन था?
आई, मबू,
मम्मी,
ताई,
माँ,
माई,
मोजी,
माझी आवे,
मॉम।
इस मदर्स डे अपने पहले सुपर टीचर की शान बढ़ाओ और सरकारी नौकरी घर लाओ। जी हाँ, टेस्टबुक सुपर कोचिंग लाया है एक अमेजिंग ऑफर जहां आपको मिल रहा है 20% का एक्स्ट्रा डिस्काउंट और 33% की एक्स्ट्रा वैलिडिटी सिर्फ और सिर्फ इस 13, 14 और 15 मई को। इतना ही नहीं, अब आप जीत सकते हैं एक स्मार्टफोन सुपर कोचिंग की तरफ से और दे सकते हैं अपनी माँ को एक तोहफा। तो अगर आप स्क्रीन पे दिए गए एग्जाम्स की तैयारी कर रहे हैं, तुरंत जाइए और टेस्टबुक सुपर कोचिंग में एनरोल करिए। देश की सभी माँओं को मदर्स डे की हार्दिक शुभकामनाएं।
Hello everyone, good evening. This is Shefali Singla, and in this session we are going to discuss the different ways of solving a recurrence relation. So this is one of the very important concept from algorithms, and on the basis of this you can expect a direct equation. That means you might be given with the recurrence relation and you have to return the time complexity, or you have to find out the time complexity for some given code or code snippet. So from that, first of all, we need to write a recurrence relation, and ultimate goal is to get the time complexity. So we'll be solving the recurrence relation. So if you have understood clearly that how to solve a recurrence relation, then we need not to worry, or we need not to cram the time complexities for different applications and so on. Okay, so the main agenda is to cover only the different methods of solving the recurrence relation. So basically we know that uh, recurrence relation term is coming from the term that is recursion. So a recurrence relation is nothing but when we are writing a recursive statement in the form of a relation or in the form of a function, that is known as recurrence relation. Okay, so it's kind of an equation that describes the function in terms of itself. That is also the definition for a recursion. Recursion means when we are solving a function in terms of itself, or when a function is making a call to itself, that is known as recursion. तो जब रिकर्सिव स्टेटमेंट को हम किसी इक्वेशन की फॉर्म में लिखते हैं, दैट इज नोन एज रेकरेंस रिलेशन. Obviously there are two important points in the recursion. What is that? जब भी हम कोई भी रिकर्सिव प्रोग्राम लिखते हैं तो उसमें इंपॉर्टेंट पॉइंट क्या है? अब फंक्शन खुद को कॉल करता जा रहा है. इफ वी वांट टेक केयर ऑफ द टर्मिनेशन कंडीशन, यानी कि जब तक हम सिस्टम को नहीं बताएंगे कि कहाँ पे कौन से सिनेरियो में ब्रेक करना है, then it will go to the infinite loop. So it is very important to clearly write the termination condition, otherwise you won't be getting any output and it will go into the infinite loop. Okay, so same goes with the termination recurrence relation. So in recurrence relation, when we are writing equation, we will be defining the recursive statement as well as the termination condition. So we have to take care of two statements. One is the recursive statement, and other one is the termination condition. So let's understand this with the help of an example, that what is a recurrence relation and what is the meaning of that equation. Very good evening, Shubham. So let's assume that we are interested in sorting n numbers. Okay, so I'm using the concept of like merge sort. So if we have n numbers which I want to sort, so the very first step is I'll be dividing these n numbers into two equal parts. जब sorting की बात हो रही है, this means हमें elements को ascending या descending order में arrange करना है, and ultimate goal is to return all the elements in some particular order. So here I am going to divide these n elements into two parts, because ये कब करेंगे? When the problem is very large. Just consider that if we have only one number and we have to return the sorted order, how much time is it going to take? It will be taking some constant time. or might be taking fraction of seconds, because एक ही number है तो definitely it's sorted only. And if we have two elements, we have to sort it out. Then again, it will be taking fraction of seconds. Now consider if we have 10 elements to sort. हो सकता है कि it may take 30 seconds, and if we have 52 elements to sort, then it might be taking around like 1 to 2 minutes. And if there are 100 elements which we need to sort, it is going to take more time. So this concludes that if we are increasing the size of the problem means number of elements to be sorted. Here the problem is to sort the given n elements, right? So when we are increasing the problem, the time complexity is increasing. Time complexity means sort करने के लिए ज़्यादा time चाहिए. So best and the one possible solution is divide the large problem into the small problem. I am basically giving you the overview of divide and conquer because it is based on the concept of the recursion. So first of all, we'll be dividing. आपके पास कोई task है and let's assume we are not able to perform it. तो best approach क्या होती है? Divide a bigger task into the small task and then start working on those small tasks, right? Same goes here. If n is a large number, then we are going to divide this into two parts. अगर टोटल 100 एलिमेंट्स है तो एक पार्ट में आएंगे 50 एलिमेंट्स, दूसरे पार्ट में भी 50 एलिमेंट्स. सो बेसिकली इट कम्स आउट टू बी n by 2. Now again 50 elements is still a large problem. So again I'll be dividing this into two equal parts. I'm dividing it into two equal parts. n by 2 है already. So it comes out to be n by 2 divided by 2 is n by 4. n by 4. Like this, we'll keep on dividing the problem into the small parts until we reach to the termination condition. Termination condition is what? When we are left with one element. क्योंकि जब एक ही element बचेगा तो definitely it is sorted only. We have to keep on dividing it until we are left with only one element, and this leaf level is representing the termination condition. So this is the concept how to write the recurrence relation. So let's learn something about the recurrence relation. So first of all, whatever operation we had to perform on n elements, अगर हमें 100 elements को sort करना है, here we had 100 elements. I was interested in sorting these 100 elements. तो मैंने problem को divide किया. अब problem को divide करने के बाद भी same function apply कर रहे हैं, right? सब problem के ऊपर भी same function apply कर रहे हैं. So if the function name is t, I want to apply the function t on n elements. तो इसका solution कैसे मिलेगा? First of all, we need to get the solution of the subproblem 1, that is t n by 2. कैसे solve करेंगे? By making the same function call. Then I'll be making the same call on the second part of the problem, n by 2. This is making a call recursively. If n by 2 is large number, again it is going to divide it into two parts. After that, अगर आपको merge करवाना है, ultimate goal is to return all the elements, so some additional time is required. So I can write this as 2t n by 2 plus n. Okay, so this is coming up from the recursive statement. This is if n is greater than 1. हमने ये बोला कि termination condition भी define करनी है. So if n is equal to 1, then it is going to take constant time to return the solution. If n is equal to 1, then it is taking constant time. So this is nothing but this is an example of the recurrence relation. Okay, so first part is determining. This is determining the recursive statement. Recursive statement, and this is the termination condition. इतना क्लियर हुआ? Recursive statement को आप ऐसे भी देख सकते हो. The given problem which was containing n elements is divided into two equal parts. Two equal parts means one part is containing n by 2 elements, other part is containing n by 2 elements. Usually this is In majority of the problems is it's n by 2, but it's not the mandatory case कि हमेशा problem को solve करने के लिए हमें दो equal parts में ही divide करना है. It depends on your problem and it depends on your solution, that which approach, which method you are going to use. Okay, so don't restrict yourself that every time the problem will be divided into two equal parts. That's not the case. So simply this is determining there are two parts and each part is containing half of the elements. In each part, n by 2 elements are there, and if total n elements are there, then additional time required to return the solution is n. This is some additional function. Okay, is this clear? I'll be using this again, this recursive statement format when we'll be talking about the recursive tree method and the master's theorem. Okay, I hope that the overview of recurrence relation is clear. Now the ultimate goal is to solve. आज का एजेंडा क्या है? To solve a recurrence relation. तो इस recurrence relation को solve कैसे करेंगे? यहाँ तक clear हुआ? So in order to solve the recurrence relation, there are three methods. One is the substitution method, recursive tree method, and the master's theorem. Okay, generally we can say that if t of n is given as 2t n by 2, मैं पिछले एग्जाम्पल ले रही हूँ. फॉर एग्जाम्पल दिस वॉज द रेफरेंस रिलेशन. तो मास्टर्स थ्योरम विल वर्क. मास्टर्स थ्योरम की कुछ रिस्ट्रिक्शन है. It cannot work on all the formats. So restriction is if the recurrence relation is of format a t n by b, I'm calling this as f of n. Okay, so condition is master's theorem will work if a is greater than or equal to 1. That means this value should be greater than equal to 1. Denominator में something should be present. And b को हम बोलेंगे it should be strictly greater than 1. क्योंकि अगर equal to 1 आएगा then there will be nothing in the denominator. So b should be strictly greater than 1. If this condition is true, only then we can apply Master's theorem. Otherwise, Master's theorem is not applicable. Definitely, there are a few cases which are defined under the extended Master's theorem. Let's see how much we can cover in today's session. Is this clear? So this is the constraint. Otherwise, the Master's theorem is the easiest and the super fast method to return the time complexity, but there is some constraint on the Master's theorem. So we cannot apply Master's theorem on all the cases. Recursive tree method में it's basically beneficial when the problem is divided into different parts and it's containing different number of elements, or you can say that non-uniform partition is there. Then in that case we will go for recursive tree method, and substitution method is like anywhere at apart from the condition, apart from the case which we are going to follow in the recursive tree method, will go for substitution method. अगर uniform distribution हो रहा है, definitely will go for substitution method. If the different parts are containing the different number of elements, then it's difficult to maintain or keep track of the equation in the substitution method. So that's why first of all I'll be starting the discussion over the substitution method, followed by the recursive tree method, and then the Master's theorem. Any recurrence relation which can be solved using the substitution method can also be solved using recursive tree method, but Master's theorem में हर एक recurrence relation आप solve नहीं कर सकते. This condition has to be satisfied. Is this difference clear? यहाँ तक clear है सबको? So this was just an introduction to recurrence relation and the different methods for solving the recurrence relation. Anyone having any doubt or query till this point? I do not understand one thing in NIC batch, the response and the interaction level is very good, whereas interaction level is very very low in GATE. जबकि मुझे personally ये लगता है कि GATE aspirants are like more dedicated towards their preparation, क्योंकि गेट की प्रिपरेशन लग के करते हैं और जब एक बार हो जाती है तो बाकी एग्जाम्स इजी लगने शुरू हो जाते हैं, बट कोई एनर्जी लेवल दिख ही नहीं रहा है. Okay, so let's start with the substitution method. What do you understand by the term substitution? Let's start with, we'll be solving 5 to 6 recurrence relation using substitution method. So first of all, can you tell me that what is the substitution method, or what do you understand by the term substitution? Most of the recurrence relations that I'll be taking, these were asked in the GATE exam, or these will be the recurrence relation that we'll be using extensively. So we need to mention two conditions. We need to mention two statements. One is the recursive statement and other one is the termination condition. So when a function is making a call to itself, that means we are solving a larger problem in terms of the same function in terms of itself. So that is the recursive statement. So this is saying that t of n is equal to t of n minus 1 plus n if n is greater than 1. That means if the problem is large, then we'll be making a call like this. And if n is equal to 1, that means this is determining the termination condition. यानी कि अगर n की value 1 हो जाती है, then it will be returning 1 only. This is the termination condition and this is the recursive statement. So on the basis of the given condition, we can easily determine here if n is equal to 1, I'm going to substitute the value 1 here, then it is equal to, termination condition is given as, if n is equal to 1, then it is going to return 1. This is what we have got from the termination condition. Now, let's solve the recurrence relation. Substitution means आप एक function की value find करते हो in terms of the other, and you are going to put that value at the place of that function. That is known as the substitution method. So here we are given that t of n is equal to t of n minus 1 plus n. Since this is the first question, so I'll be writing each and every step in detail, but after that we'll skip few. Okay, so I need to get the value of t of n minus 1. T of n की value आपको मिल गई. Now, in the similar pattern, I want to find out t of n minus 1. What will be that? जहां जहां पे n है वहां वहां पे n minus 1 substitute कर दो. So, at place of n, will be substituting n minus 1. अगर n minus 1 at place of n, and minus 1 will come as it is, plus n की जगह पे अब हमारे पास हम किसकी वैल्यू कैलकुलेट, if here we had n, then it is returning plus n. Here we are calculating the value for n minus 1, so it will be returning n minus 1. So this is the value for t of n minus 1, that is nothing but t of n minus 2 plus n minus 1. Make sense? Similarly, we can calculate the value for n minus 2. This will be t of n minus 3 plus n minus 2. T of n minus 3 will be equal to T of n minus 4 plus n minus 3. Yes? Now, according to the substitution method, we have to substitute the values here. This is the very first step. Now, substitute the values. T of n minus 1 की value substitute करो. It is containing two terms, that is T of n minus 2 plus n minus 1 plus n. Right? This is step 2. Now substitute the value of t of n minus 2, that is nothing but t of n minus 3 plus n minus 2 plus n minus 1 plus n. This is step 3. Substitute the value of t of n minus 3, it is n minus 4 plus n minus 3. बाकी सारी की सारी terms as it is आएंगी, right? बाकी equation में there will be no change. N minus 2 plus n minus 1 plus n. So this way we'll keep on substituting the values. ये कब तक substitute करनी है? जब तक हमें equation समझ में नहीं आ जाती. Now you must have observed the pattern. and try to get the termination condition. एक एक value substitute करके तो हम termination condition पे पहुंच नहीं सकते, because we do not know the exact value of it. So we need to understand, in order to get this termination condition t of 1, n में से हम ऐसा क्या subtract करेंगे? From n we are subtracting something. So what should I subtract from n such that the result comes out to be 1? Because for 1 the termination condition is defined. Quickly write in the chat section that from n, what should I subtract so that the final value, final result comes out to be 1. If we have the value of n as 5, 5 में से मुझे क्या subtract करना है कि result 1 आए? 5 minus 4 is 1. Similarly, if the value of n is 20, 20 minus 19 is returning 1. So n में से क्या subtract करेंगे? n minus 1. So it will be t of n minus 1 plus n में से क्या subtract किया? n minus 1. In order to get this step will be repeated for n minus 1 times in order to get the value 1. n में से अगर यहाँ पे 4 subtract हुआ है, here we are subtracting 3. So n minus 2. And so on. बाकी सारी की सारी equation as it is आएगी n minus 3 plus n minus 2 plus n minus 1 plus n. Right? Simplify this. It comes out to be t of 1 plus n minus n will be cancelled out. Minus and minus is plus 2, and so on up to n minus 3 plus n minus 2 plus n minus 1 plus n. Correct? Now, simplify this. This is 1 plus 2 plus 3 and so on up to n minus 2 plus, basically what series is this? Ultimately क्या होगा आपके पास? substitution method में आप value substitute करते रहोगे जब तक आपको series समझ में नहीं आ जाती. At the end you will be getting some series and you have to solve that series. So this is nothing but this is the series for natural sum series, and we know the formula for natural sum series. Verify करने का तरीका आपको बताया हुआ है. It is n into n plus 1 divided by 2. जब हम time complexity return करते हैं, that is the general or approximated value. So here this is the constant. We can ignore this because you know that we are working on the priori analysis, which is going to return the approximated values, not the exact values. So constants can be ignored. Out of the quadratic function and the linear function, obviously quadratic function is greater. So we can say that t of n comes out to be order of n square. And this is the time complexity for the first recurrence relation that we have considered. It's order of n square. Is this clear? This was a very simple example. Quickly give me the confirmation if it's clear. See, next question onwards, I'll not be writing these statements because ये सिर्फ मुझे बताना था कि जो भी given function है, in terms of that function, you have to get the value of the other terms and just substitute it. This is how substitution method works. Very, very simple. Just get the function and substitute it at the correct place. Okay? Make sense? This is for the students, those who are joining, those who have joined this session for the first time, guys. I have an official Telegram group, that is Shefali Ma'am Testbook. So you can join this group to get the PDF of all the YouTube sessions. You can ask your queries in this Telegram group. You can directly interact with me. You can participate in the quiz and the polls which will be conducted in this Telegram group, and the link is given in the description box, or simply you can search for Shefali Ma'am Testbook. Easily you'll get the link. And also don't forget to subscribe the channel, because you will, if you are interested in learning more and more concepts during the live session, so in order to get the notifications and important announcements, everything will be posted in this Telegram group. Okay. All right. So let's consider the next recurrence relation. T of n is equal to T of n minus 1. Instead of addition, now I'm taking multiplication if n is greater than 1, and this is returning 1 if n is equal to 1. So again, we are given with the termination condition and the recursive statement, and we have to return the time complexity for the same. So the first statement is the recursive statement, because here a function is making a call to itself. So this is a recursive statement. And next we have the termination condition. You have 2 minutes to try this one. At least try to get the equation. Anyone who is learning this concept for the first time? Obviously, this is the question that I'm asking from the students, those who are following the session live. जो लोग बाद में recordings देख रहे हैं, तो obviously आप अपनी speed adjust करके session attend कर सकते हो, है ना? Do you want to give it a try? Come on, guys. Okay, just try to solve this question along with me. So T of n is given as T of n minus 1 into n. This is step 1. I need to substitute the value of T of n minus 1. So it will be n minus 1 substitute. If it was n, then we were getting n minus 1. n minus 1 means we'll be getting here n minus 2 into, अगर यहाँ पे n है तो n से मल्टीप्लाई करवा रहे हैं, n minus 1 की वैल्यू कैलकुलेट करवाइए तो it is n minus 1 into n. This is step 2. n minus 3 into n minus 2. This is the value for T of n minus 2, and remaining terms will come as it is, n minus 1 into n. This is step 3. We'll be following this step for n minus 1 times. Reason is same that we have discussed in the previous question, because if I'll be subtracting n minus 1 from n, then only we'll be getting here the termination condition. Termination condition is given as T of 1 as 1. So in order to get 1, I'll be repeating these steps for n minus 1 times. So here we'll be getting T of n minus 1 into n minus n minus 2, and so on up to n minus 2 into n minus 1 into n. Okay. Now simplify it. It comes out to be T of 1 into 2 into 3 and so on, n minus 2 into n minus 1 into n. This is nothing but T of 1 is given as 1 into 2. You can skip these steps, but I'm providing the detailed solution so that you can refer it later on. And also the students, those who are understanding this concept for the first time, it will help them to understand each and every step. Okay, तो जब आपकी प्रैक्टिस हो जाएगी आप ये सारे स्टेप्स को स्किप कर सकते हो. So this is nothing but this is n factorial. We know that n factorial is equal to n into n minus 1 into n minus 2 and so on up to 1. So this is n factorial. ये वैल्यू हम रिटर्न करते हैं लाइक value wise, but time complexity wise, if we have to get the greater function, this is like n into n into n into first term. अगर आप देखते हो n into n into n into कितने times n multiply हो रहा है, 1 से लेकर it is going till n. So this means that this is equal to n raised to power, this is approximately equal to n raised to power n. Asymptotically, n factorial को हम n raised to power n लिख रहे हैं. क्यों लिख रहे हैं? I'm repeating this again because when we are returning the time complexity asymptotically कैसे return करते हैं? We have to get the greatest function. अगर आपके पास दो terms है like n into n minus 1, what will be the greater function? n into n is n square, n into 1 is n. So greater function is n square. Similarly here, the first term is n. जब हम n को multiply करेंगे n into n into n into n, how many times we are multiplying this n? For n times. So ultimately it comes out to be n raised to power n. That's why I'm saying that asymptotically n factorial is nothing but that is n raised to power n. So obviously we have got the answer. So t of n is nothing but that is order of n raised to power n. This is returning the exponential time complexity. Okay, this is the answer for this question. Clear? Let's go to the next question. T of n is equal to T of n by 2 plus C if n is greater than 1, and this is returning 1 if n is equal to 1. So basically this is the recurrence relation that we are given with. So here you can determine the recursive statement and termination condition. Recursive condition and termination condition. So what is the termination condition here? If n is equal to 1, then it is returning 1. So we can say that t of 1 is equal to 1. Now this is different type of problem. Here there is some term present in the numerator. So let's start with the first term. T of n is equal to T of n by 2. What is the C? This is constant. That means it is independent of the size of the problem. So T of n by 2 plus C. Now I need to get the value of T n by 2. n की जगह पे हम क्या substitute कर रहे हैं? Now we are substituting n by 2. So it comes out to be T n by 2 square plus C, and one constant is already coming. So simply we can write this as T of n by 2 square plus 2C. This is first step, this is second step. Similarly, when we are substituting the value of T n by 2 square, it will be T n by 2 cube plus C. 2C पहले आ रहा है, so it comes out to be 3C. So T of n by 2 square or 2 cube now plus 3 into C. This is third step. Now we do not know how many times we need to perform this step क्योंकि n by n नहीं कर सकते, n by n is 1. तो n times step repeat करेंगे? No. Let us assume that we are repeating the step for k times. So ultimately it comes out to be T of n divided by 2 raised to power k. अगर first step है, then it is 2 raised to power 1 plus 1 into c. If it's the second step, then it is n by 2 square 2 raised to power 2 plus 2c. If it's for the third time, then n by 2 cube plus 3c. अगर kth time है, then it comes out to be n by 2 raised to power k plus k into c. ये तो हमारे पास जनरल आ गया, but k is a variable that we have considered for our evaluation, but actually in the given function there is no variable k is given. So ultimately we have to find out that what is this k. Termination condition के t of 1 is equal to 1. So this means that I want this term to be equal to 1. कैसे करेंगे? n by 2 raised to power k हमें क्या चाहिए? 1. From this, can you find out the value of k in terms of n? Yes, let's simplify it. So it comes out to be 2 raised to power k is equal to n. I want the value of k, so we need to take log on both the sides. Take log base 2 on both sides. Yes? So this comes out to be k is equal to log base 2 n. Now substitute this value here. We have considered this value as 1. So ultimately this comes out to be t of 1 plus k kya ho gaya? This is log n. Right? C is constant. So we can ignore it. T of 1 is nothing but that is 1. Termination condition is given as 1. 1 plus c into log n. So what is the greater function? This is a constant. Independent of the problem size, c is constant. We can ignore it. So the greatest function is logarithmic function here. So we can say that the time complexity for this recurrence relation is order of log n. But this is the recurrence relation that we could have solved using मास्टर्स थ्योरम. हम इस पे मास्टर्स थ्योरम अप्लाई कर सकते थे. कैसे? a की वैल्यू इज 1, a should be greater than equal to 1, तो कंडीशन सेटिस्फाई हो रही है. डिनोमिनेटर में समथिंग शुड बी प्रेजेंट, इट्स प्रेजेंट हियर. So we could have solved this recurrence relation using Master's theorem as well. इसके बाद add to solve some questions. तो हम Master's theorem के साथ करते हैं. Master's theorem की practice हो जाएगी. You can solve the same recurrence relations using substitution method. तो जो भी recurrence relation मैं Master's theorem में लूंगी, आप वो सारे recurrence relations को substitution method से कर सकते हो. Okay, so this is how substitution method works. I have taken very simple and very basic examples. Anyone having any doubt? मैंने सिर्फ वो examples लिए ताकि आपको basic concept समझ में आए कि how this substitution method actually works. Guys, quickly give me the confirmation. After this, we are moving to the concept of the second method, that is the recursive tree method. Hurry up. या तो कुछ नेटवर्क इशू है और यू गाइज आर नॉट अटेंडिंग द सेशन सीरियसली. लाइक बीच में लाइव आए फिर चले गए और यू गाइज आर नॉट रिस्पॉन्डिंग. Okay, anyways, let's move on to the next concept, that is recursive tree method. That is the second method for solving a recurrence relation. Recursive tree method. Now, here, obviously name itself is saying that here we are going to construct some tree. We have already discussed if a recurrence relation is given like a t n by b plus f of n. Okay. मास्टर्स थ्योरम के लिए हम कंडीशन देख चुके हैं. बेसिकली व्हाट इज recurrence relation representing? A is representing the number of subproblems. This indicates that a problem is divided into how many subproblems. N by B is representing the number of elements in each subproblem. And f of n is representing the additional time required to return the solution. This is some additional time required. Okay, and for Master's theorem we know that condition is meaning same है, कोई भी method ले लो. This is how we read any recurrence relation. And for Master's theorem, is applicable. What was the condition? Already I have discussed that. is applicable if, what is the condition? So there are two conditions: if A is greater than equal to 1 and B is strictly greater than 1. Okay. So first of all, let's understand the concept of recursive tree method. Recursive tree method. Let us assume that the recurrence relation is given as T of n is equal to 3t n by 3 plus n. So this means that the given problem, the original problem is having n elements. Original problem में हमारे पास n elements हैं and these elements are divided into, this is representing the number of parts. कितने parts में divide हो रहे हैं? This is divided into 3 parts. Part 1, part 2 and part 3. Each part is containing 1/3 of the elements. So if in the original problem we had n elements, so here we'll be having n by 3 elements. Here we'll be having n by 3 elements. Here also in the third part also we'll be having 3 elements, right? Again, the problem will be divided into, each problem will be divided into 3 parts until and unless it is reduced to a small problem. So this is n by 3 square. This is n by 3 because already total elements are n by 3 and further we are dividing it into 3 parts. So this is n by 3 square, n by 3 square, n by 3 square, n by 3 square. So in total 9 parts are there at this level. In each part there are n by 3 square elements. So we'll keep on dividing this into 3 parts. Next step पे जाके फिर 3 parts आ जाएंगे. Here we'll be having 3 parts again, 3 parts again, like this. कब तक divide करेंगे? Until the problem reaches to the leaf level. Leaf level means the problem is reduced to a small problem. Small problem means there is only one element. So if this is level 0, this is level 1, this is level 2. So let us assume that there are k levels in a tree. Okay, so there are k levels. We are going to repeat this step for k times. So ultimately here at the leaf level, each leaf will be representing 3 n by 3 raised to power k. And each leaf node will be representing only one element. So this is behaving like your termination condition, क्योंकि जब हम tree पे work करते हैं, then definitely the leaf node is representing the termination condition. On the basis of this, we can calculate the value of k by taking the log, like we have solved in the previous question. So from this, we'll get k is equal to log base 3 n. So we have to repeat this for we have to repeat this step for k times, that is log n times we have to repeat it. Time complexity find करना means total how much time is required to solve a particular problem. इस problem को solve करने के लिए कितना time चाहिए? At first level, if n elements are there, then it requires n time, right? अगर n elements है तो कितना time चाहिए? N. So this means that it requires n time. If n by 3 elements are there, it requires n by 3 times. So n by 3 plus n by 3 plus n by 3. At this level, it comes out to be n by 3 plus n by 3, n by 3. So what is this? This is 3n by 3. So ultimately, it comes out to be n only. Right? At second level also, it requires n time. At this level, this is 9 terms are there. 9n by 3 square, that is taking n time. यानी कि हर लेवल पे n time चाहिए और कितने levels तक? For log n levels, right? So I can simply write this as t of n is equal to n time is required at the first level, then n time is required at the second level, then n time is required at the third level, and so on. कब तक? We will be adding this for log n times, right? n को add कर रहे हैं for n plus n, तो this comes out to be n log n. Make sense? So time complexity comes out to be n log n. What I have done is, if I'm writing something like n plus n plus n, तो आप क्या कर सकते हो इसमें से, take n common, it comes out to be 1 plus 1 plus 1, this is 3n. Similarly, n plus n plus n, अगर 5 times करेंगे, that comes out to be 5n. What I'm doing here is, I'm adding n plus n plus n plus n, कितने times, log n times, so that means it is going to return n log n. So the time complexity for this recurrence relation is, it's n log n. Is this clear? So this is how recursive tree method works. A quick recap over the recursive tree method. You will be given with the recurrence relation. According to that, you have to construct a recursive tree, and at each level find out that how much time is required. जब हम time complexity की बात कर रहे हैं, तो definitely हर level पे जितना time चाहिए will take sum of all and will get the time complexity required to solve that particular problem. Make sense? But definitely here the problem is divided into 3 parts, and each part is containing the same number of elements. So definitely here we can use either the substitution method or recursive tree method or master's theorem. इस recurrence relation पे तीनों methods easily work करेंगे. But specialty क्या है recursive tree method की, if a problem is divided into more than one part and it's not containing the same number of elements, at that point of time this recursive tree method is beneficial. Let's consider one example. Let us assume that the recurrence relation is given as t of n is equal to t of n by 3 plus t of 2n by 3 plus n. Have you observed one thing? Here, the problem is divided into 2 parts. First part is containing n by 3 elements. Second part is containing 2n by 3 elements. अब यहाँ पे सोच के देखो कि अगर आप substitution method follow करते हो, you will be substituting the value of n by 3 as well as you will be substituting the value of 2n by 3. Again, in the next step, you will be substituting the value. So it's going to be very complex to get an equation. And ultimately, substitution method mein goal is to get an equation and solve that equation to get the time complexity. So that means on these type of recurrence relations will not be using the substitution method. Here we are not getting a value for a. So we cannot use master's theorem. So these are the type of recurrence relations where we follow recursive tree method. ये क्लियर हुआ सबको कि रिकर्सिव ट्री मेथड कहाँ पे यूज करना है? Guys, is this clear to everyone that where to use the recursive tree method? If you'll be giving the confirmation, I'll take more number of examples. Okay, so let's try to solve this question. Here in the original problem, we have n elements and the problem is divided into 2 parts. First part is containing n by 3 elements. Second part is containing 2n by 3 elements. Yes. Again, we'll be dividing this problem. Now, instead of n, we have n by 3. So this is divided into 2 parts. Here we have n, 1/3 of the original elements. 1/3 means it comes out to be n by 3 square. And this comes out to be 2n by 3 square. 1/3 of the original elements. 2n by 3 का 1/3 कितना होगा? It will be 2n by 3 square. And this comes out to be 4n by 3 square. This way we'll be again dividing this into 2 parts and we'll keep on dividing this. Kitne levels? We need to identify that how many levels it is going to create. So if it's repeated for the k times, what should be the value of k? Should I divide this by 3 or 3 by 2? यहाँ पे n को हम किससे डिवाइड कर रहे हैं? On one side we are dividing n by 3 and on the other hand we are dividing n by 3 by 2. 3 by 2 is nothing but that is 1.5, right? So when will be getting the more number of levels? जब हम किसी वैल्यू को 3 से डिवाइड करते हैं या फिर ग्रेटर नंबर से डिवाइड करते हैं, definitely will get less number of levels. So here we'll be getting more number of levels when it is divided by 3 by 2, right? So ultimately this comes out to be k times. So that means log n with the base 3 by 2. Why I'm taking the base 3 by 2? Because this is going to create more number of levels. For better understanding, if you are confused, you can consider the value of n. For example, n is equal to 90. So n by 3, n comes out to be 30, then 10, then approximately 3, 3.33 hota hai, and this is 1.1, approximately 1. So it has created the levels. And if I'm going to divide this by 1.5, 3 by 2. So you can calculate it, and this is going to create more number of levels. So that's why we have to focus on the more number of levels. तभी हम time complexity find कर पाएंगे. So number of levels will be log n with the base 3. I hope that base 3 by 2. Now, on each level, how much time is required? Recursive tree method में हम लोग क्या कर रहे हैं? We are constructing a recursive tree, and each level we are looking at how much time is required. So if n elements are there, then it is taking additional time of n. Here n by 3 के लिए n by 3 time चाहिए, and 2n by 3 के लिए 2n by 3 चाहिए. Since the base is same, we can take the sum. This is also returning n only. Here also n 3 square is 9. N 3, 5 and 4, 9. 9n by 9, this is returning n. So at each level, n time is required. So easily we can say that the time complexity for this one is n plus n plus n. Or let me write here, is equal to n plus n and so on up to log n times. So time complexity comes out to be n order of n log n with the base 3 by 2. There is no hard and fast rule कि हमेशा आपके पास n log n time complexity आएगी. This is just जो अभी हमने examples consider किए. By chance in this we are getting n log n in both the cases, but there is no hard and fast rule that every time this is going to return n log n. So it depends on at each level how much time it is taking. And the similar question was asked in the recent GATE paper, not in 2023. It was asked in 2022. You can check it out, and there we were not getting the time complexity as n log n. Definitely log n levels will be there in a tree, but हर level पे time जो आएगा वो n होगा, that is not mandatory. So it is based on the given function. So this is about the substitution method. I hope that this is clear to everyone. Now let's talk about the master's theorem. So in today's session, we won't be able to cover the concept of the extended master's theorem, but no worries. I'll discuss the concept of extended master's theorem in some other video. एक अलग से session ले लेंगे in order to cover the concept of the extended master's theorem. And if you guys don't want to wait for the next weekend, क्योंकि during this week we will be covering the concepts of the DBMS. So just ping that in the Telegram group so that I can plan a master class on the extended master's theorem. Okay, master's class में हम extended master's theorem कर सकते हैं. So third method for solving the recurrence relation is master's theorem. Now this master's theorem says that we have already discussed the condition. This is applicable when A is, I've discussed it many a times, plus f of n. Okay, so this is applicable if A is greater than or equal to 1 and B is strictly greater than 1. Okay, तो solve करने का तरीका क्या है? First of all, you need to identify A and B. आप A और B को identify कर लोगे. उसके बाद blindly find out the value of n raised to power log A with the base B. Find out this value. After that, do the comparison. This is step 1. Find out this value. After that, compare whatever you have obtained in step 1 and f of n. कितने केसेस बनेंगे? जब दो फंक्शंस को हम कंपेयर कर रहे हैं, then there are 3 possibilities. Case 1. Okay, let me write this on the other side, otherwise it may go beyond the image. So there will be 3 cases after doing the comparison. Case 1. N raised to power log A might be greater than f of n. Case 2. This value might be smaller than f of n. Third possibility is both are equal. This is equal to f of n. Now it's very simple that when we are returning the time complexity, we always return that in the form of the greater function. तो यहाँ पे greater function कौन सा है? Greater function is n log a, but definitely masters जो basic masters theorem है, this is saying that f of n is some polynomial function, so we have to consider the value and the difference should be some constant. दोनों functions के बीच में power में जो difference आएगा that should be constant, but I'm not going into that much depth. We'll be covering that when we'll be talking about the extended masters theorem. I'm just giving you the overview, okay? Otherwise it will be too much for today's session. So since here this function is greater, very good evening Nishu. After a very long time, I guess you are attending the live session. Good to see you. So here, since n raised to power log a is greater, so we can say that the time complexity will be, it's always returned in the form of the greater function. So theta of n raised to power log a, because this function is greater. Okay, and if f of n is greater, then we'll be returning the time complexity in terms of f of n. If both are equal, तो आप किसी भी form में return कर सकते हो. If I'm writing t of n, let me write the solution for the third case here. Case 3. If n raised to power log a with the base b is equal to what we are getting for f of n, then in that case we can write this time complexity as both are equal. तो आप कुछ भी लिख लो. You can also write this as n log a, or you can write this as theta of f of n. अगर सिर्फ इतना ही लिखते हैं तो what will happen? We do not know whether this function was greater, that's why we are returning this time complexity, or f of n was greater, that's why we are returning this time complexity. So in order to break the tie, in order to avoid the condition, here we'll add logarithmic term. Both will be returning the same time complexity. आप f of n की form में ले लो या n raised to power log a की form में ले लो, one and the same thing. Reason? Because anyhow both the functions are equal. Yes? But again, I'm telling you, I'm not going into the technical definition of the different cases of the Master's theorem. Here we are assuming that this is a polynomial function, but we may get the logarithmic function as well. तो जो basic Master's theorem है वो सिर्फ polynomial, अगर f of n polynomial function है, then only we can apply the basic Master's theorem. But if here f of n is some logarithmic function, then basic Master's theorem won't work. Then we have to consider the cases of the extended Master's theorem. Extended नाम से समझ में आ रहा है, that is the extension of the basic Master's theorem. Is this clear? So if function is logarithmic, then can't apply basic master's theorem. So what is the solution? Then use the concept of extended master's theorem, which I'm not going to cover in today's session. Extended master's theorem. Make sense? Guys, make sense? So let's see how we can return the time complexities. Uh, okay, third recurrence relation जो हमने substitution method से solve किया, let's consider that. Let us assume uh, I'm going to apply the master's theorem in order to find out the complexity. Recurrence relation is given as T of n is equal to T of n by 2 plus C. We have solved this, right? So can you tell me that what will be the time complexity? Here, find out what is the step one. Identify A and B. Check करो कि master's theorem apply हो पाएगी, बिल्कुल हो पाएगी, because here A is 1 and B is 2. If you have identified the value of A and B, then the very first step is to find out n raised to power, क्योंकि यहाँ पे हमने क्या बोला है, this is polynomial function, this is nothing but C means n raised to power 0. So n raised to power log A calculate करवाना है, so this comes out to be n raised to power log 1 with the base 2. 1 can be written as 2 raised to power 0 and 2. So ultimately it comes out to be n raised to power 0. N raised to power 0 is nothing but that is constant. So here f of n, we have got here f of n is equal to constant. अब जब आप दोनों functions को compare करोगे, this is same. So this means that here we'll be applying the case 3 where n raised to power log a is equal to f of n. So the time complexity is f of n. F of n is what? That is constant. And constant can be ignored. In order to break the tie, we have to take log n. And this is what we have got by using the substitution method. जो मैंने third question लिया था, that was the same recurrence relation and we were getting the time complexity as log n. So this is how you can use this master's theorem in order to get the quick results. So I'll be taking 4 to 5 more questions and then we'll end our discussion. And in case if you have any doubt or query, you can write that in the chat section, because after this I'll be discussing your doubts and then we'll end our discussion. Next one, T of n is equal to 2t n by 2 plus constant. What will be the time complexity for this recurrence relation? You can solve it by using any method. I just want a quick response. What should be the answer? Great. Theta of n is the right answer, because here A is equal to 2, B is equal to 2, दोनों condition satisfy होगी, and f of n is equal to some constant number. Find out the value of n log A. This is n raised to power log 2. So this is coming out to be n. Now compare it with constant function. So obviously linear function is greater. So we can say that T of n is equal to theta of n. Very good. Next question. Third. T of n is equal to 4tn by 2 plus n. Answer. Here, if you identify A is 4, B is equal to 2, and f of n is n. I guess ये questions आपके orally हो जाने चाहिए, so 30 seconds are more than sufficient. Very good. So here, when we'll calculate the value of n raised to power log a, this comes out to be n raised to power log 4 with the base 2. That is nothing but n square. Out of these two functions, obviously n square is greater, so we can say that t of n is equal to theta of n square. This is related to case 1. So example number 2 and 3 is related to case 1. Let's move on to the next example. T of n is equal to 5t n by 5 plus n square. Solve it. N square. Okay. So here A is equal to 5, B is equal to 5, and f of n is equal to n square. N raised to power log A, that comes out to be n. And if we compare these two functions, so clearly n square is greater. So t of n is equal to theta of n square. This is an example of case 2. On the previous one, I had applied case 1. Before this also, we had applied case 1. This was an example of case 3. Is this clear? One last question, fifth recurrence relation. T of n is equal to 3t n by 3 plus n log n. Nishu, I'll come to your query after discussing this question. Can I apply the basic master's theorem over this recurrence relation? Here if you observe, अगर हम pattern देखते हैं तो a is equal to 3, b is equal to 3, that's fine. But f of n is n log n. This is not a polynomial function, so I cannot apply basic master's theorem over it, right? So this is not polynomial function, not polynomial function. So we cannot apply basic master's theorem, but definitely we can solve this recurrence relation using extended master's theorem. So over this we need to apply extended master's theorem, which we have not covered yet. Master's theorem. Okay. So get comfortable with what we have discussed in today's session, and After this, we'll talk about extended master's theorem. So just half an hour is required, but today we had a session for 1 hour. So I'm going to end this discussion here. Have you taken growth of functions? No, not yet. Actually, I'm covering the concepts of DBMS first because algorithms काफी बार हो चुके हैं. But I took this session randomly, ये टॉपिक randomly उठाया because there were many students those who were struggling with finding the time complexities. तो पूरे algorithms में problem आएगी if you are not comfortable with finding the time complexities. So जो weekend sessions है like Saturday and Sunday, so these are the marathon sessions. In case if you guys are facing some problem with any topic या कोई topic आपको लगता है कि it's very difficult and you are unable to understand that, you are unable to solve the questions from that topic, then feel free to write that in the Telegram group. Accordingly, I'll select the topics for the marathon session. Monday to Friday, I'll choose the topics on my own, and Saturday, Sunday, I'll take the sessions according to the request. जो भी maximum majority students बोलेंगे, I'll go with those topics. Okay. So guys, you can join this Telegram group. Here you can give your comments and feedback. Uh, and also I'll share this PDF in today's uh, I'll share the PDF of today's session in this Telegram group. And to join this group, you can follow the link given in the description box. I'm going to share my screen. I can show you that how you can join it. Ma'am, how can I join your classes? Just give me 2 more minutes, Nishu. I'll show you that. And also I'll discuss the schedule कि किस टाइम पे आप देख सकते हो. वैसे तो मैं जितने भी सेशंस होते हैं सबका लिंक टेलीग्राम ग्रुप में शेयर करती हूँ, तो आप वहां से डायरेक्टली भी ज्वाइन कर सकते हो. मोर ओवर टाइमिंग्स आर फिक्स, सो यू कैन फॉलो दोज टाइमिंग्स. ओके. Doubts and discussion will be there in this group. You can directly interact with me, quizzes and polls में आप participate कर सकते हो to keep track of your preparation. Currently, the Mother's Day sale is going on. Today is the Mother's Day. All right. So first of all, let me share my screen and then I'll discuss the schedule. I hope that the screen is visible. ओके. सो अभी आपके पास ये सेशन चल रहा होगा. तो जैसे ही बेटा आप इसके डिस्क्रिप्शन में जाओगे ना, हियर दिस इज द फर्स्ट लिंक फॉर द सेशंस फॉर NIC and NILET master classes. Second one is to join NILET NIC super coaching. Third link is for GATE super coaching telegram link. So this is the link of the telegram group. You can join this link or you can search for Shefali ma'am Testbook. Okay, this is first thing. Second thing, if you want to get the complete subscription or you want to join the super coaching batch for the gate, currently sale is going on. In fact, Testbook pass पे भी sale चल रही है, आपकी screen पे display भी हो रहे हैं, up to 90% discount is there on the Testbook pass, and yearly you have to pay just 299. In this, you will be getting lot many questions, mock tests, and access to the previous year papers. So you can join that, and you can see the playlist of the NIC classes. I had taken the sessions in the NIC batch as well, so you can follow this playlist. So जितने भी links हैं, all the useful links are there in the description of this video. Super coaching के benefits हैं, you can attend any number of sessions from the single topic, and multiple recorded sessions are available, which are provided by Gate Forum, Digimento, and Nimbus, and me and my team. So आप सारे batches की बेटा rating देख सकते हो. You can see the rating here, and obviously this is the rating given by you guys only. So just go to it, explore करो इसको, and if you are not confident enough कि कैसे sessions होंगे, then join this live series or the demo classes, and you will get an idea that how the sessions will be carried on. And apart from that, you will be given with the study notes of each and every subject. So under the study notes, there are the PDF of the detailed notes as well as the short notes फॉर्मल नोट्स आर देयर, ये आपके पास एग्जाम से पहले बेनिफिशियल होते हैं. एंड एज वी टॉक अबाउट द प्राइसिंग, तो इस टाइप के प्राइस बहुत लो है बिकॉज ऑफ द मदर्स डे सेल. So we have 3-year plan, 2-year plan, and 1-year plan because this much time is required for the gate. But the benefit is, uh, under the sale, you will be getting 33% extra validity. Like if you are purchasing 3-year course, तो 1 year की extra validity मिलेगी. If you are purchasing 2-year course, you will be getting 8 months extra, and if you are purchasing 1-year course, you will be getting 4 months extra. So basically, for 16 months, you just have to pay 10,799. This is the recommended one. So third year and fourth year students can go for this 1-year plan, and those who are in first year, second year, third year, according to your level और जितना आपको लगता है कि आप कितना dedicate कर सकते हो time preparation के लिए, accordingly you can opt between a 3-year and 2-year plan. So in order to get the full-fledged benefits, ये extra validity and everything, just apply the code here, that is Shefali S. Okay, just apply this code, and this that will take you to the final payment page. Now it's the time to discuss the schedule for the upcoming sessions. यहाँ तक किसी को कोई doubt? Apart from this, there is a lucky winner every hour who can win a smartphone. तो जब आप पेमेंट करोगे तो obviously आपका नाम automatically add हो जाएगा, and you can also be the winner of the smartphone. Okay, so जो sale अभी चल रही है, that is for valid for the textbook pass as well as for the super coaching batch. Now the schedule, Monday, tomorrow is Monday, so weekdays में what I'm covering is, in the weekdays, I'm currently covering the concepts of the DBMS. So already we have covered few basic concepts from DBMS. So Monday I'll be taking a session on normalization. Weekdays में हमारे पास Monday to Friday we will be having free sessions for which you do not need any subscription. Free sessions, दो free sessions आएंगे daily. एक आएगा YouTube के ऊपर. This will be an hour session, and other one will be masterclass. This will be on the Testbook platform. So agenda is कि जो topic हमने cover किया है, same day हम उस topic की practice कर ले, previous year questions कर ले. So whatever concept we will be covering on YouTube, on the basis of that concept, PYQs will be covered on the same day. Time for YouTube session is 4 p.m. to 5 p.m. And for this masterclass, time is 8 p.m. to 8:30 p.m. Okay, so anyhow both the sessions are free, और इससे क्या होगा, जो भी आपने टॉपिक कवर किए साथ के साथ आपकी प्रैक्टिस हो जाएगी. Is this clear? So this is how you can join my classes. टाइमिंग क्या रहेगा, किसका टाइमिंग, मैंने दोनों सेशंस का टाइमिंग बता दिया आपको. सुपर कोचिंग में जो लाइव सेशंस आएंगे, those will be focusing on the quick revision and the live doubt sessions. मास्टर क्लासेस का लिंक कहाँ से मिलेगा, टेलीग्राम ग्रुप का लिंक कहाँ से मिलेगा, दैट विल बी that is given in the description box. So I guess the timings are clear. This is the timing for the YouTube session and this is for the master class. Same day, तो आपके पास बीच में 3 hours का time होगा during which you can revise the concept and you can actively solve the previous year questions. Okay. So this is all from my side, and yeah, enjoy your evening, and I'll see you tomorrow at the same time. Thank you so much, guys. God bless you. Take care.